All right, we're going to do 1.5 tomorrow because it takes a little longer, and today we don't have a lot of time. So I'm paring this down to 2 slides. There's one concept, the second slide on there that says verifying that things are inverses of each other. We'll go over that next week. It's easy, but we don't need to do it right now. So let's talk about inverse. First of all, what does the word inverse mean? Opposite, right? So what's the inverse of multiplication? Division. What's the inverse of squaring a number? Taking the square root, okay? We know what inverse is. We are going to find inverses. I'm going to show you how to do it graphically, but we're going to find it algebraically. But I want you guys to understand graphically what this looks like. Okay, here, look. In green, I have the function f of x equals x plus 4. And in yellow, it says f negative 1 of x equals x minus 1. So first of all, look at the notations. In green, that's function notation. In yellow, it's inverse function notation. What do you think makes it inverse? The little negative 1. So when you write your answer, when you algebraically find your inverse and you write your answer, put that little negative 1 on it, okay? Secondly, look at the functions themselves. Do you see how they're opposites of each other? Okay, x plus 4 and x minus 4. All right, so now look at the domain and range of green, x and y values, and the domain and range in yellow. How are they different? They flip the x and the y. All right, inverse means flip, switch, opposite, however you want to say it. So graphically, if you have a function and it says, what is the inverse? Or is there an inverse? Whatever. You take the x and the y and you do what to them? You flip them. When you graphically verify if something is an inverse, you take the domain of the original and make it the range. You take the range of the original and make it the domain. And if they flip, then that's the inverse. So when you guys algebraically, it's all we're working on today is algebraically. When you find your inverse, you have to use that inverse notation, that f negative 1. That's what I'm saying here. So here's graphically. Do you see the dark black squiggle? And then the inverse is the like gray one. Do you see how they flipped over that sideline? That's how that'll happen. Whatever the function is, when you switch the x and the y, they flip. That's it. Okay? Now we're going to talk about algebraically. This is how you do it from the book. I'm going to write down even simpler steps. We're going to go through 3, and you're going to say, hey, this isn't so bad. So step number 1, replace f of x with what letter? With y. Perfect. Step 2, and this is the most important step. You're going to switch the places of x and y. Because what does inverse mean? Opposite, right? You flip them, switch. So when algebraically, when you are trying to show or to find the inverse, you replace f of x with y. You switch the places of x and y. And then you're going to solve for y. And you have to have inverse notation in your answer. So f negative 1, g negative 1, whatever the letter is. So let's look at this. Now, I'll kind of show you. Lots of you like to know, how can I check my answer, make sure I'm right? Let me show you how. What's the first step? Yep, replace f of x with the letter y. What's the second step? Switch the places of x and y. So this becomes x equals 5 minus 3y divided by 2. Everybody with me? God bless. And now we're going to solve for y. So I have to undo everything. What am I going to do first? Multiply by 2. What you do to one side, you do to the other. So you have 2x equals 5 minus 3y. Now what? Subtract the 5. Perfect. 2x minus 5 equals negative 3y. What's my last thing? Divide by negative 3. So you come out with y equals 2x minus 5 over negative 3. So you had your original function. How do you tell me that that's the inverse? Very good. So you're going to write f, little negative 1 right there, of x equals 2x minus 5 over negative 3. And the beauty of finding inverses algebraically is this. Look at the original. You guys see the original up here in blue? In the original, do you see how you had a positive 5 in the numerator? What do you have in the inverse? Negative 5. In the original, do you see how you were dividing by 2? What are we doing in the inverse? Multiplying by 2. In the original, do you see how you were multiplying by negative 3? What are you doing in the inverse? Dividing by negative 3. You could always go back and say, hey, did I just undo everything from the original? And it should match. You should be able to do that every time you do an inverse. Mm-hmm. Yeah, whatever letter. You can always use f of x if you want. If it's a different letter, that's fine. Just always use f. Doesn't matter. So like here, step 1. Replace f of x with a big y. Then what do I do with x and y? That's the most important step, is the switching of the x and y. So this becomes x equals 3y plus 4 divided by 5. How do I get y now by itself? Multiply both sides by 5. Perfect. So 5x equals 3y plus 4. Now what? Subtract 4. And then divide by 3. How do I write my answer? F, negative 1 of x equals, whoa, what in the world happened there? 5x minus 4 divided by 3. Look at your original and compare to your inverse. In the original, we were multiplying by 3. What are we doing in the inverse? Dividing by 3. In the original, you were adding 4. What are you doing in the inverse? Subtracting 4. In the original, you were dividing by 5. What are we doing in the inverse? Multiplying. Good. That makes sense? All right, let's look at the last one, then we're done. Look at all the things that are happening here. I see a square root, I'm multiplying by 2 and subtracting 3. So what's the opposite of a square root? Squaring. Okay, what's the opposite of multiplying by 2? Dividing by 2. What's the opposite of subtracting 3? Adding 3. Let's see if all that happens. So I'm going to change this to a y and then switch the spots. So x equals the square root of 2y minus 3. Yeah. Nothing. Good question. It's just still function notation. It's like if you have two equations, they won't, like say you had like 3 equations written at the top of something, it would be like f, g, and h, like f of x, g of x. It's just kind of the way to name different things. It's still function notation. All right, how do I get y by itself? What's the first thing I need to do? I've got to square both sides here, right? That'll cancel this out, so I have x squared equals 2y minus 3. All right, keep going. Add 3, perfect. So x squared plus 3 equals 2y. And then divide by 2, perfect. So how do I write my answer? G negative 1. If you want to always write f, that's fine. I'm not going to take off points for that, just as long as you have the little negative 1 there. But I have x squared plus 3 divided by 2. So compare, right? In the original, we were taking the square root. In the inverse, we were squaring. In the original, we were subtracting 3. In the inverse, we're adding. And in the original, we were multiplying by 2. When in the inverse, we're doing what? That's fine. No, that's fine. You're understanding that you need to use function notation, so that's perfect. If you use the wrong letter, it doesn't matter.